Hello friends, welcome to this video. In this video, we'll be discussing this interesting question number 14 inside your practical 4.2 or 2.4 MCQ. Okay, so this is nothing but A. If A matrix is given as 1 0 0 alpha 1 0 beta gamma 0, then which of the following statements are true? They have given 1 2 3 4 and the 4 options are over here. The first one is x minus 1 is a minimal polynomial if and only if, so it should be both the way true, that alpha beta gamma must be equal to 0. The other thing is what? The second is x minus 1 square is a minimal polynomial of A if and only if alpha and beta is equal to 0, alpha and gamma equal to 0 and beta is not equal to 0. The third one is x minus 1 cube is the minimal polynomial of A if and only if beta and exactly one of alpha and beta are 0 and exactly one of them are 0, exactly one of them. Okay, we'll think about it. So it is x minus 1 cube is the minimal polynomial of A if and only if exactly 2 of alpha beta gamma are 0. Okay, so definitely if you see the options, so options are 1 2 3 are 2, only 1 is true, 1 and 3 is true, 1 2 and 4 is true. So in all of them 1 is there, so 1 is definitely true, but we'll see how. Since I know this is a triangular matrix, the eigenvalues are nothing but the diagonal entries 1 1 1. Hence, the minimal polynomial for A in terms of x is nothing but what? It is same as x minus 1 cube. Characteristic polynomial, not the minimal polynomial, if I have said minimal. So, my characteristic polynomial is nothing but this. After that, the minimal polynomial for A is what? The minimal polynomial will be a divisor for this, right? It has the same roots. Hence, it will be like x minus 1, or it can be x minus 1 square, or if it is not this, then the final option is same as the minimal polynomial like this. I want to clear this one note to the students. Suppose if I have minimal polynomial as this cube and x minus 2 square, suppose, then what are the choices for the minimal polynomial? I know my minimal polynomial divide this, but there is one more thing. They both has the same roots but different multiplicity. That means I won't check for a minimal polynomial as x minus 1. Why? Because it does not has 2 as its root. So my first choice for minimal polynomial will be x minus 1, x minus 2. This will be my first choice. After that I will go for x minus 1 square, x minus 2. If it is not that, then I will go for x minus 1, x minus 2 square and so on. I will just check on all the divisors, but I will make sure they both have the same roots, but different multiplicity can be there. Okay, so this is nothing but a note for all of you. Now I will just check for this first one. So x minus 1, that means A minus I. Let me consider the matrix. Matrix is nothing but like x minus I will subtract it by identity. The diagonal becomes 0 0 0 0, lower triangular, alpha beta and gamma. If I say x minus 1 is a minimal polynomial, then my A minus I must be equal to 0. That means my alpha beta and gamma must be equal to 0, which they have given in first. So x minus 1 is a minimal polynomial if and only if alpha, beta and gamma equal to 0. Correct? If they are 0, then only I will get this as a 0 matrix. Correct? If this is a 0 matrix, then only I will get this as a alpha, beta, gamma equal to 0. So definitely first is right. Okay? Let me just check for x minus 1 square. Okay? So that means something about A minus 1 square. A minus 1 square. That means this matrix multiplied to itself. Okay? So I'll just use this only. I will just make some changes over here. So x minus 1 square, it is 0 0 0 alpha 0 0 beta gamma 0. Okay, I'll just multiply it. First row first column 0, first row second column is again 0, first row third column is nothing but alpha into gamma, second row with any column I think it is 0, and third row is always giving the answer 0. Okay, that means if this is a minimal polynomial, that means I know that not all of them are 0. Correct? At least one of them is not equal to 0. Correct? If all of them are 0, then minimal polynomial must have been this. Since they have given this is a minimal polynomial, means I know at least alpha beta gamma में से कोई तो एक है, at least one of the alpha beta gamma is not equal to 0. So that they have considered as over here, beta is not equal to 0. Okay. Also, if you see the in this case, the answer must be 0 matrix. For that, my alpha into gamma must be equal to 0. For that, my alpha can be 0 and my gamma can be equal to 1 also. Still, this matrix is a 0 matrix. And for beta, I have no choices. Means I have infinitely many choices. I can choose anything. So, according to me this option 2 is not correct, because if you consider your matrix like 1 0 0, over here 0 1 0, and over here you may choose 0 1 1. Okay, try to find out the minimal polynomial for this. Does the minimal polynomial same as this or not? Wait, so minimal polynomial is same as this, but my this conditions are not necessary and sufficient conditions. Over here I have choose beta equal to 0, also I have choose gamma not equal to 0, hence means 2 is not right. Correct, because if I make square of this minus I, okay, let me just write in detail. So suppose my a is nothing but same as this, then my a minus I square will be what? My a minus I square will be same as a 0 matrix. If you just see the multiplication over here, it will be 0 matrix. Also my a minus I is not equal to 0, since over here I have a non-zero entry. That means this is nothing but the minimal polynomial. So the second must be the wrong choice. Okay, that means it is false. Let me just think about the third one. So it is x minus 1 cube. Okay, so x minus 1 cube will be the minimal polynomial if and only if my x minus 1 square is not the minimal polynomial. Correct? So my x minus 1 square is not the minimal polynomial. That means what? That means my this thing is not equal to 0. X minus 1 square is not equal to 0, because if it is not this, my minimal polynomial is not this, then only choice is this. Means if I want my x minus 1 cube to be a minimal polynomial, I will make sure that this is not a minimal polynomial. But that means this is not equal to 0. That means this is not equal to 0. Okay, I'll just rub the remaining part since I'm working on option 3. Okay, so that means what? My alpha is not equal to 0. My gamma is not equal to 0. Okay, so that means according to that, this is a minimal polynomial of a if and only if beta and exactly one of this are 0. No, it cannot be. My alpha and beta cannot be 0. Correct? My alpha and beta cannot be 0. Okay, let me just see the fourth one. So this is also wrong. Fourth one, minimal polynomial of a if and only if exactly 2 of them. No, not exactly 2 of them. They are like exactly 2 of them. No, it's like beta is not equal to 0. And alpha is equal to 0 and gamma is not equal to 0. This satisfies this condition. Exactly of them, 2 of them are 0. Okay, exactly 2 of them are 0. That is never possible, right? If 2 of them are 0, this become a 0 matrix. Hence my a minus I square will be the minimal polynomial. Hence fourth is also not right. Okay, I hope you guys have understood. If you have any doubt, any difficulty, please write in the comment box. For now we know that option B is correct. ओके, थैंक यू गाइज फॉर वॉचिंग दिस वीडियो टिल द एंड. अगर अच्छा लगता है तो प्लीज़ लाइक कीजिए, शेयर कीजिए और चैनल को सब्सक्राइब कीजिए. ठीक है, थैंक यू.